Coral reefs are perhaps the most spectacular manifestation of life's beauty, complexity, and just the sheer profusion that can be witnessed on this planet. My lab studies reef-building corals, which are peculiar colonial animals related to sea anemones, which are able to lay down these sometimes quite elaborate limestone foundations for their own colonies. But together, they form a coral reef. And the problem is, we're losing them.
In the Caribbean in the 1970s, coral cover was high and reefs were very healthy and thriving. But since then, the Caribbean has lost more than half of its coral cover. Today's corals, the ones that still remain, are virtually hanging by a thread. What will happen next? Continual decline to near extinction, or gradual recovery due to adaptation to climate change? To be able to save the reefs, it's critical to know which of these trajectories the corals are likely to take. Our idea is to look into the past, to see how corals reacted to climate change over the last 100,000 years.
Genetic diversity and population size are inherently linked. As populations expand and contract through time, that information is recorded in the genome. So by sequencing just a few coral individuals, it will be possible to reconstruct historical population structure going back thousands of years.
In addition to unlocking the coral's past, the information contained in the genome can illuminate virtually every aspect of coral biology. And this is why we will immediately share the new genome sequences with the research community for unconditional use, so that, with your help, anyone with a good idea of how to save the reefs will have the best information resource to do so.